All right, guys, this is your second video for today, and now we're going to be talking about reflections and stretches and shrinks of quadratics. Again, you'll see, as I said earlier, we're going to be doing these from vertex form, okay? And so just like the last one, you may want to pause this video here so you can get these notes down. I'm going to go through them quickly, but to save video time and upload time, you're going to want to pause it and write some more of this down, okay? So if we change the sign out front, it reflects over the x-axis. I gave you a couple examples here. If we're just looking at x squared, a basic quadratic, more of a standard form sort of thing there, it's a negative all the way out front. But if we're in vertex form, like you see in this second little example here, it shows that we went from a -3 out front to a +3. And you're saying, wait, that went from negative to positive. That's okay. That is still our sign change, okay, all the way out front. It's going to reflect it over the x-axis. This would be a parabola that is negative out front, meaning it opens downwards, and then it goes to a parabola that opens upwards. And so what that does is it actually flips it over that axis, okay? Don't know why my pen wouldn't let me draw a parabola over there. Okay, however, changing the sign inside the parentheses of the x value is going to flip us over the y-axis. So you can see we went from there to there. That's changing inside. Or you can see right here, we had a +2 out front. +2 stayed the same, okay? But what changed was that this negative sign popped up inside the parentheses. That's going to cause us to reflect over the y-axis. That one's more rare. Most of Algebra 1 tends to do with x-axis flips, because a y-axis flip, a lot of times you could also just say, okay, that's just a translation, okay? The next thing you need to have for your notes is this second section. Multiplying by a number out front will stretch or shrink the graph. It does one or the other, kind of like the reflections. The graph will stretch, which also means get narrower or steeper, if the multiplier is greater than 1 or less than -1. Some people don't really include this one, okay? They say, oh, that's just something stretching and it reflecting. But it does stretch still by that same factor, okay? So an example would be going from x squared to 3x squared. That's going to stretch by a factor of 3. Or as you can see, this second example is really in vertex form. -2, the +5, all that stayed the same. What changed is we went from nothing out front to a -4 out front, okay? That's stretched by a factor of 4. And as it says in blue, that one's also going to reflect over the x-axis. Because going back to our previous rules, if the sign all the way out front changes, we reflect over the x-axis like it did here. So it'll stretch by a factor of 4 and reflect over the x-axis. Kind of a combination there. Shrink's a little bit different. Graph will shrink, which means get wider and flatter. You're going to need to know these two key words and these two key words, okay, for your homework. If the multiplier is between 1 and -1. Again, these ones in the negative realm are going to cause a reflection. So an example of that, there's really two ways these pop up. The first way is with a fraction showing up. Went from a regular x squared to a 1/2 x squared. This one I do want to show you on the actual calculator itself, because these ones where it gets wider are a little bit confusing. So we had x squared, and now we have a 1/2 x squared. And let's see what getting wider or flatter looks like. So the blue one is going to be our first graph here. And then we're expecting this one with a 1/2 to get wider or flatter. And wider is a really good descriptor here, because you can see it's a similar parabola. It has the same vertex because we didn't translate it left, right, up, or down with any of the numbers changing. But it definitely got wider or flatter, okay? But one of the common words used is shrunk. And what it means by shrunk is it kind of got flattened down. It kind of shrunk its overall height, its overall growth, meaning the y values aren't growing as fast now. It got shrunk. Another way this will show up, which is more rare, is in decimal form. So you'll see here we had no number out front, and then we had a multiplier out front appear of -0.25. So what this is this shrunk by a factor of 0.25. and it reflected over the x-axis, as you can see in blue there. Let's go through some examples. Here's our parent function again. A reminder, parent function means every step of the way we're restarting with that function, okay? So if we're starting with this parent function, we want to reflect over the x or over the y-axis, okay? We go back, check our notes. What did reflect over the y-axis mean? Y-axis reflection meant it changed inside the parentheses. So nothing else should change unless it tells us to. That means it's going to be parenthesis negative x minus 2 quantity squared plus 5. All right, let's go back to the parent function, change colors. Now we're going to be stretching by a factor of 3. Well, if we want to stretch by a factor of 3, it means that number just comes out front. So we multiply our parent function's binomial by a factor of 3. That should make it taller and skinnier by a factor of 3. The larger the factor there, the taller and skinnier it gets. And finally, our last one's a double one. Reflect over the x-axis and shrink by a factor of 1/4. Well, that means the 1/4 is going to pop out front. That's kind of the easy one to tell. But reflect over the x-axis, go back to your notes, check what that meant. That means the sign changes out front. This is currently a positive, meaning we need a negative out front. Well, that negative is not just a -1, it's actually a -1/4 here because of the shrink factor. X minus 2 quantity squared plus 5. Notice the -2 plus 5 stayed the same because we didn't go left, right, or up or down. We were just stretching, shrinking, or flipping over y's or x axes. Let's put it all together. Okay, the blue graph here is your parent function and the red graph is your transform function. It doesn't really give us the parent function here, so we're kind of left out in no man's land, but you'll be given multiple choice here. So you have to just kind of figure out, okay, weed out the bad options, weed out the ones that don't make sense, okay? So from the blue graph to the red graph, the first thing I notice is that it flipped over this x-axis, meaning I'm expecting a negative out front. Okay, let's see if I can rewrite that a little bit better. Negative out front. Next, let's talk about what happened with the rest of the parabola. Well, it started off in this fairly wide little format right here, kind of a normal looking parabola, and then we see it got more narrow. Okay, it got skinnier, it got a little bit longer, all right? That means we should also expect that out front we multiply by a number, or like a whole number, a large number, not a fraction, not a decimal. Okay, we should expect to multiply by a whole number. So if I was looking to try to maybe make this entire second function myself, I would be looking at what properties it has, okay? So to me, I see that it looks like our parabola, instead of being on the dead center in the origin, looks like it shifted left 1. Well, that means we would add 1 inside some parentheses. It doesn't look like it has a y value shift, so I'm thinking probably no number out here. And now's where things get a little bit to where you're just kind of guessing, since we're not really given a table or exact values or the parent function. We're just saying, hey, what number could have popped up out front? Well, we don't know what number, but we know it needs to be negative, and it needs to be some whole number because it's a stretch, so maybe a -2. Now, when it comes to multiple choice, guys, there's not going to be one that gives you -2 as an option, -3 as an option, -4 as an option. No, it's going to give you -2 as an option, and then like -1/2. You say, well, -2 versus -1/2, not that big of a deal. But if it was a -1/2, that would make a parabola get wider and flip upside down. Well, what if it gave you something like this? You say, okay, Mr. You said it's probably -2. What if it gives us a +2 right there? Okay. Well, a +2 isn't going to cause that reflection. So you're putting two pieces together. A +2 might just take our normal parabola and make it skinnier. The only thing that's going to do both of these things is some sort of positive whole number, or not positive, some sort of whole number out front that is negative, because the negative causes the reflection and the positive 2 is what's going to cause it to stretch. Which also means to get narrow, okay? So just remember all those different verbiage.